Sir, we will start within 4 or 5 minutes, sir.
No
We're
problem.
waiting
No
for
problem.
joining participants.
Yeah, no problem. Just only, I think 35 have started, no? Have joined, no?
Yeah, sir. Yeah, sir. 9:30 we will exactly will
Yeah,
start.
sure.
Okay, sir. Thank you, sir.
Okay, thank you. ಆನ್ ಮಾಡಿದ್ಯಾ? ಈಗ ಇಲ್ಲಿಗೆ ಶೇರ್ ಇಲ್ಲಿ
A very good morning, one and all. On behalf of Jyoti Institute of Technology, Department of Civil Engineering, I, Mr. Ganesh CR, Assistant Professor, Department of Civil Engineering, heartily welcome all the participants and today's speaker, Dr.U.T Vijay sir, for this last day of first session, AICTE-ISTE sponsored 1 week refresher program. Now I request our senior professor Dr. S. Kumar sir to give a brief introduction about the speaker.
Thank you, Ganesh. Very good morning to one and all. I am Kumar Srinivasan, Professor, Department of Civil Engineering, JIT Institute of Technology, Bengaluru. It's my immense pleasure to introduce Dr. U.T Vijay. Dr. U.T Vijay is serving as the Chief Scientific Officer in Karnataka State Council for Science and Technology, that is KSCST, Indian Institute of Science, Bengaluru, since 1986. He obtained his BE in Civil Engineering from Bangalore University, Master's degree in Civil Engineering from Coimbatore University, and doctorate degree in Civil Engineering from Bangalore University. His areas of interest are water-related technologies such as rainwater harvesting, traditional water harvesting system, and watershed development, applications of geospatial technologies for natural resources management, and application of 3D laser scanning technologies for archaeology and heritage conservations. He has been associated with various projects and programs in KSCST, such as rainwater harvesting, assessment of traditional water harvesting system in Karnataka, that is Kalyanis, Pushkarnis, Kunte, Gopte, and Katte, to suggest the scientific measures for restorations and rejuvenation, preparations of actions plans for watershed development, monitoring and evaluations of watershed development activities using geospatial technologies, Suvarna Bhumi Yojane, applications of 3D laser scanning technology for 3D modeling World Heritage Monuments for the prestigious preservations of cultures and heritage under Indian Digital Heritage, program of DST GOI and Karnataka Digital Heritage, that is KDH, a program of Department of Archaeology, Government of Karnataka, disseminations of nanotechnology based water purification for arsenic affected villages, and applications of geospatial technologies in natural resources management and infrastructure facilities for rural development and decentralized planning in the state under NRDMS program. He has to his credit a number of national and international publications. He has presented several papers and delivered talks and chairing in various international and national seminars, workshops, and training programs. He is a member of several expert technical committee of various academic R&D organizations and government department of Government of Karnataka and Government of India. I thank Dr.U.T Vijay for considering our invitation in spite of his busy schedule. Now I request Dr. Vijay to continue the session. Sir, now you can continue, sir.
Thank you. Am I audible?
Yes, sir. Yes, sir.
Let me share my screen. Is it visible?
Yes, sir. Yes, sir.
Okay. Thank you. So, good morning to all of you. I'm Dr. Vijay from Karnataka State Council for Science and Technology. First of all, let me thank the JIT Institute of Technology for giving me this opportunity to participate in this prestigious refresher course program. Before starting my talk, let me introduce my organization, Karnataka State Council for Science and Technology, which is one of the first state science and technology council to be set up in the year 1975, which is located in Indian Institute of Science, Bengaluru. Since inception of our council, we have been serving the state by using science and technology interventions for the development of the state, both in the area of rural as well as urban areas, under the main sectors of water, energy, education, health, ICT, geospatial technology, digital heritage technology, and so on. Especially under water, we have been serving the state by carrying out a lot of field investigations, and using advanced technologies, we have been giving a lot of scientific measures and sessions to the state in the development of both surface water as well as groundwater. Under education program, you might be aware that council has been carrying out a flagship program called Student Project Program, which has been there since 1977. The main objective of this program, student project program, is to tap and encourage the innovative ideas of final year engineering students as well as master degree engineering students to take their ideas to the market. Since 45 years, we have supported almost 12,500 projects, out of which 1,000 projects are under commercial mode. So they've been commercialized. So such kind of programs are there in our KSCST. Like this, we have around 35 state science and technology councils are there in each and every state and UT of our nation. So coming to our today's topic, I will be talking on traditional water harvesting systems and different techniques of rainwater harvesting, which is most prevalent in our country. So in my talk, I will be covering background on water harvesting, the genesis of water harvesting, then traditional water harvesting, how our ancestors, our elders used to harvest water traditionally. Then what is the present scenario of water availability, water resources, need for rainwater harvesting, then different techniques and methods of rainwater harvesting, of course, along with success stories on rainwater harvesting as well as traditional water harvesting systems, the scientific study which has been carried out by our state council. Finally, I will be giving some scientific measures for water conservation. These are all the topics I will be covering in my talk. So friends, as we all know that water is important and is an essential natural resources for being used for various uses for all creatures of on the earth, both animal, plant life, including human consumption, apart from various other uses. As we all know that rain is the main source of water resource. See, first of all, let us know what is the water resource distribution on our earth planet. See, if you see our globe, our earth is been covered, 2/3 of our area is covered by water and 1/3 is land resources. Out of that 1/3 of 2/3 of land resources, water resources, 97% is available in the form of oceans and sea, that is salt water only. 3% is available in the form of fresh water. That too, out of 3%, 2% is available in the form of ice caps and glaciers, and 1% is available in the form of fresh water. That too, in the rivers, water bodies, including groundwater availability. See, with this 3% only we have to struggle. That too, in 1% of fresh water only we have to struggle and we have to meet for all our users. If you go back to our inception of our civilization, see, water harvesting is not a new technology or any special technology or any rocket technology. It's a very simple way of harvesting rainwater. Whatever rain comes on your place, you can catch it, store it, and use it for various uses. See, it is not started yesterday or before yesterday, day before yesterday. It was started with the inception of our civilization. You can see these structures. These are the structures which were constructed by our ancestors. That too, our civilization. Even today, we can see this kind of structures in Harappa and Mohenjo-daro civilization, where it took place in the border of our country along with Pakistan and Afghanistan. Even today, you can see this kind of structures. So, with these pictures, it shows this water harvesting was there since inception of our civilization. Even if you take our neighbor country, Sri Lanka, see, they used to harvest water on top of hillocks. There is this reservoir cut into rock was used centuries ago to store harvested water, which was being supplied to the nearby villages through gravity force. Even they used to store water from their rooftops also. Nepal, if you take, they also used to harvest water naturally. Even they used to harvest water from fog water collection. They used to collect the water from fog and they used to supply to the villages settlement, which are lying downside the hillocks. Even you can see these pictures, which were being used by Uganda, using brick jars as well as lime mortar. Even earlier also they used to use ferrocement jars as well as wooden stems with lime mortar line. So let us understand what are traditional water harvesting systems. Basically, traditional water harvesting systems were constructed to store water for domestic, religious, and irrigation purposes, along with recharging of groundwater. These are environment friendly and constructed using locally available material with traditional knowledge, which are crucial to the overall ecosystem. Basically, these structures are environment friendly structures. And also, these structures are also constructed as flood control measures. These are also constructed as monuments to showcase the richness of tradition, heritage, architecture, and Eastern culture of the region. The temple tanks, kalyanis, pushkaranis, or stepped wells, which are constructed near the temples, they were playing very important roles, especially in social, religious, and cultural activities of our Indian tradition. Annual float festivals, Teposava, light festivals, Deeposava used to be conducted as part of the socio-religious activities near these water bodies. Of course, in India, it is prevalent from almost Kashmir to Kanyakumari. These are all being called various names like zincs, stepwells, Vav, Kalyani, Bauri, Bauli, Pushkarani, Kund, Talabs, Uranis, Baudi, Trankas, Nadis in different states and different regions. You can see from this picture, it is there, as I told you, it all prevalent, widely prevalent in all parts of our state, I mean our country, starting from Jammu Kashmir to Kanyakumari. Especially in Himalayan regions, they used to collect water from glaciers and store in this type of tanks, and they used to use this water for domestic as well as irrigation purposes. Then coming to this our Rajasthan as well as Gujarat area, they used to use this water. They used to harvest water in tankas, and with this, these were built by nomadic people of Madras who used to roam these grasslands. Then Kund, this is also found in desert areas of Rajasthan and some part of Gujarat. And Berry, which is 12 to 20 meter deep pits dug near tanks to collect the seepage water, which is available in the form of groundwater. Johad, which are also were constructed using locally available material, either earth or clay or something, by people of Rajasthan. Then Kadin, which is projected in Jaisalmer area of Rajasthan, they used to harvest water by constructing some bunds to store water which was being used for both irrigation as well as groundwater recharging. Then, apart from this kind of surface harvesting surface water, they also used to construct this type of stepped wells or valves or bowli, not only store the groundwater seepage, they used to showcase the architecture, culture, and history of the region in the form of sculpture as well as architecture. So you can see this beautiful stepped well called Chand Bauri, which is located in Aban area, Rajasthan, which has 3,500 narrow steps over 13 stories. They used to collect huge water in this structure, which is there in Rajasthan. If you see this right side structure, Agrasenika Bauli, which is located in Delhi, this 60-meter long and 50-meter wide and 30-meter depth step well on Highway Road in Delhi. You see this structure, how beautiful it is. Ranika Wow at Patan, which is 65-meter long and 25-meter width, having 30-meter depth, which is also considered as one of the World Heritage Sites by UNESCO, one among 35 World Heritage Sites of our country. Constructed on the banks of Saraswati River, was initially built as a memorial in the 11th century. It was constructed as a religious as well as functional structure and designed as an inverted temple, highlighting the sanctity of water. If this structure, this one, which is located in one village called Kotale in Ahmednagar district of Maharashtra, which was constructed to tap the groundwater seepage in the bottom of hillocks. Earlier it was potable. Now, with the interference of our tourists, it has become unpotable. However, this water is so cold in summer also, actually feel like standing in a refrigeration unit. Of course, Pushkarani, stepped wells or column constructed for religious purposes near temples by using locally available metals, the two lateritic bricks in Kerala. And these are all the small structures, traditional structures called Eri or tanks, Urani or small tank. Even it is being called as Kovi column in Tamil Nadu. All these structures were being used for both domestic irrigation along with groundwater recharging. Then coming to our own state, we have several types of traditional water harvesting structures. That to the main 4 types of rainwater harvesting in traditional water harvesting structures are Kalyani, Pushkarani or stepped wells, Kunte, which are constructed in the area of around one Gunta place, and Gokatte, which are meant for drinking of cattle population, that is Gokatte, and Katte structure compared to tanks. Of course, as we all know that water from these water bodies is being used for various uses, including domestic, cattle drinking, along with groundwater recharging, and even industrial purposes, and also recreation purposes also. And also we used to have wells even in our irrigation lands as well as in our house also by tapping groundwater at shallow level. These are all different types of water structures in order to tap both surface as well as groundwater. See how importance was being given to water in earlier period. We used to assemble and we used to gather near water source. And also, along with collecting water from the water source, we used to gather, we used to share our ideas, knowledge. Even in one proverb is there in Kannada, ಊರಿಗೆ ಬಂದವಳು ನೀರಿ ಬರ್ತಾಳ. Say, if any bride or new person comes to village, definitely she will come to the water source. That is water point, either common well or some common tap. So like this, we used to give lot of importance to water source, and also we used to assemble there, and we used to share our knowledge, share our ideas, and also social gatherings also are being conducted, apart from conducting religious as well as cultural activities near our water bodies. See the present status, which were constructed by our ancestors, how we are using. If you see this kind of structures are there physically intact, but see the quality of water, see the maintenance of our these structures. Due to negligence and ignorance by our both community as well as government, the structures are lying idle, and also it is being used as dumping yards. Then see the condition of this tapping of groundwater. Now you can see more than 50% of our bore wells and 90% of our tube wells with hand pumps, they become non-functional, and they become dry and become almost dead. So because of this, what is the present scenario? As per UNO declaration, there are over 663 million people still living without a safe water supply close to home, spending lot of hours, lot of time queuing or trekking to distant sources, distant places to get a single pot of water. If the same situation continues, by 2030, half of our population will face water crisis or shortage. Even if the same situation continues, by 2050, as much as 70% of our world population definitely may face freshwater scarcity. Coming to our own India, our country, more than 6 crore people even today living without a safe water supply close to their homes. Coming to our own state, Karnataka, out of 29,000 villages, more than 7,000 villages are facing both quality as well as quantity issues, including a lot of water contamination like fluoride, total hardness, iron, arsenic, nitrate, even some places uranium problem also. This picture shows the plight of how our people are struggling to get single pot of water. All these photos, they appear in our newspaper only. See how our people are struggling to get a single pot of water. Why I'm showing these pictures? If we don't give importance to harvesting the water, harvesting the rainwater, definitely we are going to face a lot of problems, as I shown in the previous slide. Here also, people are, our neighbors, they are struggling a lot to get single pot of water. See, in Ahmedabad, in Gujarat also, they're struggling to get water. Even this left photo, if you see, it is taken from one of the village in Assam, where they get almost 11,000 mm rainfall annually. They're also facing potable problem for potable water. So nowadays it has become almost common. Either we protest or we fight for water. We fight each other for water. Fighting is there from village to village, is there from district to district. It is there from state to state also. So there is a joke. I mean, almost a prediction is there. If Third World War takes place, definitely it's for water. If the same situation continue, definitely one or other day in future, we may have to get the pot of water like this. How we get diesel and petrol from petrol stations like that. So then what are the reasons for shortage of water? Of course, as I told you, even though our globe is covered 2/3 of water resources, still we have problem. Why? Because it is because of population increase. Of course, land resources is there and water resource is there from same thing only. But we have seen the population increase, then industrialization, urbanization. Of course, definitely ignorance and improper maintenance of traditional water harvesting systems which were constructed by our ancestors and our elders. We can see decrease in surface water bodies like lakes, tanks, even many urban water bodies also. We have seen deforestation all these days. Because of this, we are seeing erratic rainfall with space and time. Groundwater exploitation is being taken place. I've shown you number of bore wells and hand pumps. Almost they become different. Almost they become dry and they became dead. Why? Because of change of land use, land cover also is there. Because we have changed the land, our land use and land cover. That has been also taken place. Then also improper water resources management. And the last and but not the least, climate change and global warming. We can see this even we can in the month of December, January. Why we see we are facing rainfall? Definitely because of climate change and global warming only. Just this slide I'm showing how urbanization has affected our water storage. Many of our water bodies in Bengaluru city, they have been converted to either bus stand or complex or a golf course or even stadium also. Once upon a time, there were around 262 water bodies were there. Now we can see only 82 water bodies in Bengaluru city. Then what is the effect? See the effect. Either we see water scarcity or floods because of change of land use, land cover. Because there is no space for storage of water. Because we have all converted those water bodies into our either bus stand or housing complex or some other commercial purposes. What is the solution? As we know that for every problem there is a solution. What are the solutions for water scarcity? Just I will listed some indicative solutions. Rainwater harvesting is one of the solutions. We have potential of rain to meet water demand. Even 100 mm of rainfall, if we harvest properly, definitely we can suffice the minimum requirements of our population. Then whatever traditional water harvest systems are there, if you rejuvenate, if you restore, if you maintain properly, definitely we can use those structures also without spending much money. We can use water from these structures for various uses, including groundwater recharge. If you maintain properly of all our surface water bodies, including these traditional water systems, definitely we can suffice our purposes. Then if you treat wastewater, which is coming up out of our bathrooms, kitchen, even from industries, if you treat properly, definitely if you recycle it and you can reuse it for various uses. And if you manage the all water supply and water resource scientifically, definitely we can give solution for water users. And then of course, already we have seen deforestation. If you afforest, if you go on planting the trees more and more, wherever you find place for planting of trees, if you increase the green cover, definitely we can get more rain and we can minimize the evaporation losses and we can store water sufficiently to meet the present requirement as well as for our future generation also. So as I shown you the present situation of our traditional water systems, our council, our KSCST, Karnataka State Council for Science and Technology, we took up a study, scientific study, to assess the physical, hydrological status of these traditional water bodies, to give scientific measures for rainwater harvesting. Why? Because most of the structures are in depleted condition and became dry, resulting into the decline in their potentials. Even the temple tanks, which were enjoyed sanctimony from humans because of religious sanctity, are also under threat. Then most of the structures have become dry, and also they became almost dump yards in both rural area as well as urban area. These ancient water bodies are also polluted, resulting in water becoming dirty and unsuitable for human consumption. Also, these are also being used for sewage disposal and dumping yards and became home for mosquito breeding. With this background, we took up this study in the year of 2017, finished in 2020. Almost 40,000 structures have been taken up for scientific study, and almost each and every panchayat of our state visited by our team, and we assessed and we covered all these parameters. That is geographical location of this traditional water harvest system, along with the type of the structure, whether it is a groundwater structure or surface water structure. And we have assessed its administrative jurisdiction and who are the custodians and the type of usage and reasons for disuse, and its catchment area, whether it is from surface as well as the groundwater seepage. We have assessed the physical structures of those structures like length, width, depth, etc. Then water storage capacity also has been assessed. Metrics used for construction, along with hydrological parameters of the structure like drainage network, its catchment, storage area, then status of silt, the status of outlet and waste wear, geological and geomorphological parameters of those structures, then land use land cover of area, along with topography of the area, that is slope, aspect, and altitude. Then data of soil also has been assessed, which is playing a major role in the storage for water, along with rainfall and climate condition, groundwater level of the area, then status of water quality in some water bodies. All these aspects have been covered in our study. Like this, we have assessed both physical and hydrological status of these structures in our state. And also, we have created around 25 parameters for each structure under geospatial environment. That is called geographic information system. We have created around 25 parameters as a attribute database. And also, we have taken the geographic coordinates. We have created the spatial data of those structures. We have superimposed or overlaid on various thematic layers like its drainage network, surface water bodies network, soil, topography or slope, geological, as well as hydrogeomorphic parameters. So we have assessed integratedly, and we have given the scientific measures for rejuvenation of these water bodies. And also we have created district-wise, taluk-wise, or state-wise location of water bodies by integrating all these thematic layers. If you click on any symbol like this in GIS environment, it will give you its present photograph along with the around 25 parameters pertaining to that particular water body. Like this, we have studied scientifically of this around 30,500 structures. This table shows the type of structures and number of structures for each district of our state. We have prepared scientific reports like this, and we have submitted to the concerned DC or Jilla Panchayat Chief Executive Officer for taking up these water bodies for rejuvenation under various schemes. Fortunately, these structures have been taken up by our state as well as district administration under various schemes such as MG Narega, that is a National Rural Employment Guarantee Program, Jalamrita, even the new program which is given by which they call is given by our Honorable Prime Minister of our India, that is Catch the Rain, Jal Shakti Abhiyan. All these structures have been taken up for rejuvenation, resetting, restoration of the structures under these schemes. So these are all the pictures shows the present condition of this traditional water structures in our state. And what is the summary of our observation? When you have studied around 13,550 traditional water harvesting structures, we found around 25% of our structures are in good condition or under use. Around 35% of the structures are not under use, even though structures are in good condition due to various reasons, they're not being under use. Around 20% of the structures, they are in bad conditions, wherein structures are damaged, collapsed, and we could find no proper inlet as well as outlet, because for any surface water structures, there should be some outlet in order to drain off the excess water, which is above the maximum water level. Around 40% of structures have no water. Some 60% of structures have water have no water due to various reasons, including depletion of groundwater also, maybe. Around 30% of structures are polluted with physical as well as chemical components. This is what also we have assessed. And most of the structures are filled with silt. 90% of the structures, we could see lot of silt deposit in the structures, which has resulted in the decline of the storage capacity of the structures. Around 20% of structures are used as dumping yards. Then, of course, we could see around 50% structures have been encroached by the neighbors for various uses also. Then 15% of water bodies get sewage water and effluents from RO water purification plants and even industries without any proper treatment. Definitely, because of this, water quality also get affected. Then we could also see lack of security in monitoring and maintenance due to lack of awareness and knowledge and commitment by the both community as well as the government. This is what we have observed as part of our study. And we have given lot of scientific measures for restoration and rejuvenation of these water bodies. Some indicative measures have been listed in this slide here. That is, clean the inlet, feeder channels. That's very important because inlet and catchment area is very important, and bail out the contaminated and stagnant water to store clean water. Remove the weeds, algae, garbage, bushes, slush, which is there, which is accumulated in the water bodies in order to maintain the cleanliness. Then, of course, provision of proper silt traps for inlets and feeder channels, along with provision of proper outlet should be provided wherever outlet is not there. Then desilting is the most important activities to be carried out in order to desilt the silt deposit in the water at regular intervals in order to enhance the water capacity as well as to maintain the good quality of the water. Then we have given measure for restoring the damaged and collapsed steps, side walls, stone pitching wherever damage has taken place. And we have also given session for providing proper outlet to allow the runoff. Allow the stored water, which is more than maximum water level. Plus, it should be made to allow the runoff and surface water flow during rainy days. We should give the provision for that. And also, wherever the structures are located in the urban area and also near to the building, we can also give provision for roof water harvesting, which can be stored in the structures. And to enhance the aquatic culture, we can suggest rearing of fish in these water bodies and planting of trees along the sides of the water bodies to maintain the ecological balance. proper slopes also should be maintained for main and side bunds, for stability and durability of the side bunds as well as the main bunds for surface water bodies. In order to give the importance to these water bodies, especially which are located in the vicinity of the urban area or settlement, we have given some suggestions like to develop these structures along with walking paths, planting of trees, seating arrangements needs to be carried out to make the water bodies as tourism spots for locals as well as tourists who are visiting that area. So as the impact of our study, this, as I told you, these structures have been taken up by the district administration for rejuvenation. These pictures are showing how these structures have been taken up for rejuvenation. And finally, earlier it was like this during the rejuvenation work. And this picture shows the present situation. At least it's cleaned up and water storage capacity also has been increased. This Kalyani or stepped well, which is located in Bidarhalli village in Bengaluru East Taluk of Bengaluru urban district. With a beautiful octagonal shaped Kalyani, which is located near Chikbalapur Taluk, which was also like this earlier when we have visited. Based on our report, the structure has been taken with fencing and cleaning and even desilting also. See, now it looks like this. This structure is located in Tumkur district of Kotigara Taluk. See, this kind of stepped wells or Pushkarani or Kalyani, it will be having one more well within the water body. Because in order to ensure even water availability during summer season, 90% of the structures definitely will be having this kind of well within the water body. As I told you, many structures which are in the vicinity of the urban area, they've been developed like tourism spots by having walking paths, seating arrangements, planting of trees. So a lot of visitors are locals, they can come and spend time. And even if you plant the trees, it will minimize the evaporation losses of this water body. Also, it will become home for many birds to come and sit in this trees. Like this, if you develop any water body, definitely it will balance the ecology and environment of the area. These tanks have been taken up for rejuvenation in Chamaranagar district. This was the before condition, and these are the photographs after rejuvenation of this water body. Then coming to the second one, that is rainwater harvesting, which is the one of the solution, rainwater harvesting. Let us see what is rainwater harvesting. As I told you earlier, it is the systematic collection of rainwater to be stored for various future uses, including groundwater recharge. The main concept is very simple: collect which falls on surface as well as on the roof of your area, store it properly and use it for various uses, and excess water can be recharged. That is very simple. The main three steps: collect, store and use, and recharge. This is the very simple concept involved in rainwater harvesting. As I told you, very important steps involved in rainwater harvesting, that is collection, whether it is from roof as well as from surface or from open air, store it, channelize it, convey it or filter properly, store it and allow the water to be discharged. Excess water which is being which is going out of this as a outflow of from your storage structure. As I told you, very simple process of collecting water from the rooftop as well as from the surface. Even if you tie clean sari or dhoti, you can store it this water either from in this pot, earthen pot, even small bucket also. Even if you store on top of your toilet also, you can use it naturally without any pump, without any this thing. I mean, naturally you can use this water. So there are major 3 types of rainwater harvesting are there. That is, one is, as I told you, rooftop rainwater harvesting, surface water rainwater harvesting, which is coming out of your landscape, parks, even stormwater drains, even our road surface also. The third one is natural collection of stormwater, which is coming, which is flowing in the natural streams, drains, or catchments of groundwater discharge also. There is Kalyani, ponds, tanks, Urania, so on. So these are all the 3 main important types of rainwater harvesting. If you see why rainwater harvesting is required, definitely to conserve or augment the storage of surface as well as groundwater, to reduce the groundwater table depletion, to improve the quality of groundwater, to avoid, as I told you, rainwater harvesting is one of the measures for flood mitigation. To avoid the flood and water stagnation in urban areas, you have to go for rainwater harvesting. And also to arrest seawater intrusion in coastal areas. Definitely, in order to save the consumption of electricity and other infrastructure required for civic bodies to supply water for our urban population, definitely is required. As we know that rainwater also is one of the ultimate source of fresh water. We have potential of rain to meet water demand, for various uses. So this is why we require rainwater harvesting. Then what are the important components of rainwater harvesting? If you take rooftop rainwater harvesting or even surface water harvesting also, definitely one is your collection area, that's catchment area, whether it is roof or surface or even playground or even road surface also. That is very important. Then of course, if you take roof, we have flat roof as well as sloping roofs. Then conveyance or transportation is either through pipes or through some channels. Of course, with some minimum filtration is required. Then storage. Then excess water can be recharged through wells, open wells or bore wells. So these are all the important components of rainwater harvesting. There is your catchment area, transportation, filtration, storage, as well as groundwater recharging component. These are the very important components of rainwater harvesting. If you see the different types of components one by one, the first one is roof or surface. If you take roof water harvesting, definitely we'll be having 2 types of roofs. That is, one is flat roof like this. The second one is slope roof, depending upon different materials that I will be showing in the future slides. So what are the different types of roofing materials are there? Definitely RCC roof is there, ACC, asbestos, galvanized iron, fiber, asphalts, wooden shackles and shingles, slates, even some clay tiles along with mangrove tiles. These are different kinds of various materials being used for roof of our buildings. Then after catchment area or your roof, channelization is also very important. There are 2 types of channelization is there to convey the water from our roof to storage tank, either through gutter or either through pipes. If it is from sloped roof, gutter is being used, and if it is from flat roof, pipes are being used for conveyance of the water from roof to storage tank. Let us see the different types of gutters. They are available in different shapes: semicircular, U shape, rectangular, trapezoidal, even V channel also. If you see the different kinds of materials, bamboo materials, which is available locally in some places, then fiber gutters for sloped roof, and GI gutters, PVC, many kinds of gutters are there to be used for conveying of water from roof to storage tank. If you take pipes, stone, earlier we used to have stoneware pipes, then wrought iron, PVC, AC pipes, cement pipes, cast iron, GI, copper, stainless steel. Depending upon your usage, you can use different kinds of materials like this for conveying water from surface to storage tank. If you take apart from collection, conveyance, you should have some filtration media in order to filter some physical impurities. There are two kinds of filters are there. One is wall mounting filter as well as to be constructed on the surface. Wall mounting filters are being used for domestic use or up to some extent, up to some 10,000 liters capacity of rainwater harvesting. We can use this kind of materials. See, one thing we should keep it in our mind. These wall mounting filters can be used for only for some rainwater systems till some small structures to medium structures, especially domestic structures. We can use this kind of structures. And also we should see that these filters will only filter physical impurities. This will not clean any chemical contaminants. This will clean only physical impurities which carried by water from the surface, your roof surface. Then also, depend upon your usage, you can go for sand bed filter or pebble bed filter like this with the three different layers like pebbles or big size aggregates, coarse aggregates or some fine aggregates, and along with sand, separated by different nylon sheet, which can be used for cleaning after usage. If you allow water from inlet, it will filter through this media, this sand, fine aggregate and coarse aggregate. You will get some filtered water from this filter media, from your sand bed filter or coarse your pebble bed filter. Depend upon your type of storage tank, either a sump, underground sump, or your surface storage tank. This kind of structures which can be constructed based on the site condition. Then coming to the last and important component of rainwater harvesting, that is storage tank. We can now both ground level or surface tanks, and also we can have even underground sump also, depend upon your site condition. You can go for either surface tank or underground sump. Even if you have different levels in your building, you can go for even constructing storage tank at different levels in order to use this stored water for the downstream bathrooms or toilets using gravitational force, using natural gradient without any power for pumping water from storage tank to overhead tank. Even depend upon your structure, depend upon your usage, and also go for this kind of storage tank like this at the various level. It can be constructed. For example, see, this is one Rai Sampata Kendra where the storage tank is being constructed above the toilet, and water from this tank, storage tank, is being used naturally without any pump. This is how you can plan depend upon the site condition. Even here also, this story for the ground story buildings, definitely you can use this water from this storage tank without any pump. If you see the different materials are being used for storage tanks, you can go for earthen part, depend upon the availability, plastic, fiber, metal, even HDPE, ferrocement, cement concrete, brick masonry, even brick masonry with lime mortar, wooden stems with some lining with lime mortar, even some places even wooden tanks also with lining also are being used for storage of rainwater. This kind of storage tanks also can be used for various use depend upon our site condition as well as site condition also. So one thing we should keep it in our mind, when you store rainwater in surface tank, we should not allow the outlet air vent like this, because always when you keep it for open, that is for light as well as air, definitely water gets polluted. In order to prevent, it should be tightly covered, it should be air free as well as light free. So that is why, as light is not passing from downwards to upwards, you should keep this air vent like this, not like this. If you keep these structures in your storage tank air free as well as light free, definitely you can store rainwater for more period. Then apart from surface tank, definitely we can go for underground sump like this, using different materials like brick masonry or stone masonry or even RCC also. Even brick masonry with lime also, we can go for these kind of structures, depend upon your usage pattern as well as site condition also. Then coming to, apart from storage, coming to recharge, groundwater recharge, there are a number of pavers are available with proper holes, which can be used for groundwater recharging on walk paths, even on roadside also, even in parks also. These are the different pavers, perforated pavers, which are available in the market, which can be used for groundwater recharging. Like this, we can use this perforated as well as with holes, and even stone slabs with from open joints can be also used as groundwater recharging components on road surface or walk paths in the parks and playgrounds. Even almost we have given some technical design to around 600 parks in Bengaluru city like this. Any rainfall which falls on walk paths can be stored for usage, or even which can be stored in which can be allowed to recharge the groundwater through some silt traps like this, and which can be stored like this for groundwater recharge. And also we can use some dead wells, open wells, for also to be used as groundwater recharging like this. And also we can recharge the bore wells using rainwater, which is coming from either roof or from surface. But one thing we should keep it in our mind, please don't use this pit kind of structure for rainwater harvesting around the bore well, because which may block the micro holes of bore wells after the casing pipe. That is why we suggest we can go for some silt trap to allow the water which is coming from your roof as well as the surface, allow this silt to be deposited like this, and allow the clean water to the some recharge well. Then from here we can allow the filtered water to go to this bore well. If you recharge like this, definitely your bore well recharged successfully. This is one of the bore well which is located in the KIDWAI hospital campus, which is giving very good yield, which is giving very good result. If you adopt this kind of recharge method, definitely we can rejuvenate lot of dried bore wells as well as different borewells. And also, we can go for groundwater recharging along the road surface, having infiltration trenches like this, which is coming from this road to which flowing out of this road. If you allow the percolation trench like this, definitely your groundwater also get recharged from like this. And if you construct some infiltration trenches at different intervals, some 3 to 4 feet depth, 2 feet width, and some 4 to 5 feet depth. If you fill some boulders, your waste materials, and some aggregates like this, then filled with some coarse aggregate, fine aggregate with sand like this, and if you close this mesh like this, definitely whatever water flows on this drain can be allowed to percolate, allowed to recharge the groundwater. Anyway, because it is being flown in this drain, so if you allow this kind of infiltration trenches in the different at different regular intervals, definitely if you allow water to percolate through this infiltration galleries for groundwater recharging. As part of dissemination of rainwater harvesting technology, and also as part of promoting rainwater harvesting technology, KSCST has set up rainwater harvesting help desk, and also we have one rainwater harvesting cell since almost 15 years in KSCST in IICTE campus Bengaluru. We have been supporting government, private, multinational, and various organizations and institutions to take up rainwater harvesting. Technically, we have been supporting by giving a detailed project report. And also we are conducting a lot of awareness programs in order to promote, create awareness on rainwater harvesting. And also we give a lot of trainings also for plumbing contractors, architects and engineers in Bengaluru city and parts of our state. And also we have been conducting fish competitions and various demonstrations for school as well as college students. And one very important theme park we have constructed along with the Bengaluru Water Supply Board in Jayanagar. That is called Sarram Visheshwaraya Rainwater Harvesting Theme Park, which is located in 40th class of Jayanagar, 5th block. This theme park is meant for demonstrating live models of rainwater harvesting, different models. Around 27 different rainwater harvesting models have been demonstrated in 1.5 acres of land in this park. That's Sarram Visheshwaraya Rainwater Harvesting Theme Park. Here, we have constructed different types of structures, both surface water and groundwater recharging structures. Around 27 different models are there in this structure, which is being maintained by BWSSP and also technically supported by KSCST. Around 85 training programs have been conducted by KSCST in order to facilitate around 2,650 engineers and architects of our Bengaluru city. And we have conducted more than 500 awareness camps. We have supported more than 500 government and private organizations to go for rainwater harvesting. And also, we helped the Bengaluru Water Supply Board to make rainwater harvesting compulsory and make mandatory in Bengaluru city in order to store water either for reuse or for recharging. So out of around almost 20 lakhs houses, around more than 1.5 lakhs houses already have got construction of rainwater harvesting. Apart from all these activities, we have also developed an app called rwh_advisor.info rainwater harvesting app. We have developed with the help of IIC and other R&D institutions, we have developed this. It is also available in Google Store. rwh_advisor.info. You can try this. As part of our case studies, which have been supported by KSCST, you can see our Shakti Sauda, that's Vidhan Sauda, which is the main icon of our Bengaluru city, which is in the capital city of our state. Around 6 lakh liter capacity of rainwater harvesting system has been installed in Vidhan Sauda. The water from this rainwater harvesting storage tank being used for gardening, flushing in toilets of this toilet, flushing, and even gardening also. Apart from washing of vehicles also in this Vidhan Sauda. Then the one more icon, High Court. Here also we have supported this High Court maintaining organization, that is PWD. Around 5 lakh liter capacity of storage tank has been constructed, which is also being used for various uses, including gardening as well as flushing in the toilets. Then, of course, the main administrative office of our Bengaluru city, that is BBMP. There, actually, we are supported to go for rainwater harvesting like this. And of course, this is our office. We are also using rainwater for various uses, including gardening and flushing in our toilets. We have been using it for almost since one decade. Definitely, we can take up rainwater harvesting in apartment also. This shows one of the apartment. And also, we have supported Kingere BD Workers Association complex. Even domestic houses also can go for rainwater harvesting by using locally available materials. See, this bamboo off-cut bamboo is used as a gutter instead of PVC like this. This is Yendattur, one of the village. Almost 80% of the houses, they have rainwater harvesting in Mysore district. This is from one of the village in Koppal district. Both these two photographs. This is from one of the village in Mysore district. Like this, we have supported both urban as well as rural area. Also, rainwater also is being used in even rural schools also. Around 23,000 schools have been supported by KSCST through Rural Development Panchayat Raj Department, which were constructed by the respective Nirmati Kendra for respective district administration. This rainwater, which is collected from the rooftop of their schools, being used for midday meal schemes, washing the utensils and as well as plates and cups and tumblers being used by the school children. Of course, is one of the successful program, but nowadays because of not properly being maintained, some 25 to 30% of schools are not using rainwater for their uses. So definitely the maintenance of rainwater harvesting structures is very important. In the last slide, I will be showing the measures for cleaning of maintenance of rainwater harvesting. Then how to calculate the yield of roof water? If you have roof like this, you should divide your whole roof into different grades, depend upon the shape of the grade. Assess the roof yield, depend upon the shape of the grade. Either it's a square or rectangle, A into B. That will give you the area, and the rainfall if you take, you will get the yield. That's roof yield. Area into roof yield. Rainfall will give you the roof. Roof yield. That is rainfall yield. If you have sloped roof like this, it has to be multiplied by extent area of slope as well as width. If you instead of A and B, you should be multiplied by A and Y. That is the extent area of the slope. That will give you the roof area of your slope. and if it is multiplied by your rainfall, it will give you the roof field of your sloped roof. Just one example I'm showing here. That is calculation of roof field water potential from 30-40 site, that to RCC house in Bengaluru city. As we know, 30-40, that is 1,200 square feet. If it is converted to square meter, that's 112 square meter. It should be multiplied by our annual rainfall of our place. That is 900 mm. 900 mm is our annual average rainfall of Bengaluru city. Then it has to be multiplied by coefficient of runoff, because whatever rainfall occurs, falls on your roof or on surface, definitely will not get 100%. Definitely it has to be multiplied by some runoff coefficient, depend upon the type of roof or type of surface, type of land, or type of even road surface also. If you multiply by this area, rainfall, and runoff coefficient, you will get potential of rainwater. If you take like this 112 square meter, that is 30-40 site, then 0.9 is the rainfall. That's converted to 0.9 meter, because this should be same meters only, and 0.8 is the conversion factor, because we are using RCC, because this is the roof type is RCC. RCC 0.8 is the conversion factor. I will be showing one slide which shows the different runoff coefficient for different surfaces or even different types of materials which are being used for in roof also. If you multiply 112.9 in 0.8, you will get 80.64 cubic meter multiplied by 1,000 liters. You will be getting around 80,640 liters annually. So depend upon number of persons, then consumption and non-rainy period, you can go for designing of storage tank. Or as a thumb rule, we take around 1/10 of your annual storage capacity. That's around 8,000 to 10,000 liters capacity can be can be taken as storage capacity for storage tank, which can sustain or we can suffice the requirement of your people, household of 30-40 site. These are the different runoff coefficient: RCC roof, asbestos sheet, GA sheet, tile roof, plaster of bricks, metal sheet, then clay, soil surface, different, because percolation losses will be there. Parks also depend upon the land, you have to go for this runoff coefficient. Then playground will depend upon the surface, asphalted road surface, railway yard, brick and concrete pavement, lawn. Only GA sheet, if you use as a roof material, around 90% of rainfall can be taken as runoff yield from the GA sheet. Otherwise, you have to use these are the values for runoff coefficient. So, how do you design size of storage tank? It all depends upon number of persons in the house or number of persons in the office. If it's for office, if it's for even industry, number of staff, then per capita consumption or per day consumption, for which purpose it is being used. Then number of days for which water is required. That is number of non-rainy days and rainy days. For example, if you take drinking water requirement for a household with 5 family members for the period of 8 months non-rainy period, if you get 4 months rainy at the rate of 6 LPCD, that's 6 liters per capita per day, 5 into 240 into 6, around 7,200 liters, or say 8,000 liters capacity of storage tank you can have for rainwater harvesting for single family. This small estimation I've given here for rainwater harvesting for small domestic purpose, that is 30-40 site for a residential purpose. The major cost goes to storage tank. For any rainwater harvesting, the major component goes to storage tank. If you have storage tank in your house, the remaining thing will become just very nominal. That will comes to within 20,000 rupees. Otherwise, if you don't have the sump or storage tank, so you will have to spend around 1 lakh for rainwater harvesting in residential complex of 30-40 site. Of course, I will listed here what are the uses of rainwater harvesting. As we know, rainwater can be used even domestic also, including drinking and cooking. After being tested of its quality, definitely it can be used for secondary purposes, including gardening, nurseries, flushing, washing, industrial use, water drinking, irrigation, even fire control uses also. And what are the advantages of rainwater harvesting? If you take environmentally, as we know that it is environment friendly, so a lot of energy can be saved. Economically also it is viable, very simple and cost effective. Already as shown in the previous slide. It minimizes the flood control, which also minimizes the even soil erosion also. Definitely, it will augment the water supply of both urban as well as rural water supply. So one of the augmented and alternative technique of water storage and as well as supply. Then what are the measures for maintaining the rainwater harvesting system? I've given some very indicative measures. As I told you, all main components of rainwater harvesting, starting from your catchment area to storage tank, that is your roof, channelization, conveyance, filtration, storage should be clean, should be maintained properly at regular intervals. If you take catchment area, that is your roof type or your surface, it should be roof used for harvesting should be clean, free from dust and debris or dirt. It should be cleaned very regularly. Should not be painted. It can be coated with lime. Lime whitewash is very ideal, which acts as a antibiotic material. And also roof should not be used for toilets either by human or pets or birds, because we should avoid the bird droppings as well as pets droppings also on roof types. If it's there, it should be cleaned very regularly. Provide proper gratings and filters at mouth of each drainage pipe or gutters, which is conveying water from roof to storage tank. And provision of first rainwater separator should be made to flush up the first rains, which carries a lot of debris and dirt. And also, ground should be recharged by rainwater, not after proper filtration, not with directly without filtration, not with polluted water. As I told you, before recharging, proper filtration arrangement should be made. So, as I told you, roof, conveys, there is pipes, first place filters, tank should be checked and cleaned properly and regularly. With this, I will conclude my talk. So let us harvest rain, store water, rejuvenate our ancient water bodies which are constructed by our ancestors and elders to conserve water for future use. Thank you very much.
Thank you very much, sir. Really, it was a very, very informative session. Sir, we have received few questions from the participants, sir. I will read one by one.
Yeah, please go ahead.
Sir, first question is, what are the possible techniques can be adopted to protect traditional source of water bodies like Kalyani? In Karnataka, what are the major drawbacks observed to protect traditional source of water bodies?
Okay, shall I answer or you will go for next question? Shall I answer this question?
Sir, you answer this question, sir. Next, I will read next question.
Okay. So as I told you, what we found in Karnataka, the major problems are silting of these tanks, then blockage of inlet, Then proper outlets are not found in these structures. Then physical damage, we could see these structures were being used as dump pads, and some structures have been encroached. Some structures are being used as dump pads. Then some structures are being used as allowed to dispose water effluents which is coming out of our RO plants. These are the major problems which we have observed in our study, wherein we have studied around 30,500 odd structures in Karnataka. The major problem we found is around 90% structures were filled with silt, which reduces the capacity of storage as well as which reduces the quality of water. So we have given scientific measures for rejuvenation of these structures based on the nature of problem we faced with respect to this structure. Then,
Thank you,
of course, as I told, there are different types of rainwater harvesting. One is rooftop rainwater harvesting, surface rainwater harvesting, and even groundwater structures also, which can be used as a rainwater harvesting structure system.
Thank you, sir. Next question is, integrated watershed development programs are felt necessary for site suitability evaluation for locating water harvesting structures. Do these integrate missions achieve sustainable development in rain-fed watersheds?
Yeah, definitely, because in Arsikere and other parts of our state, even our Rajasthan and different parts of our country, which witnessed the rain-fed agriculture, rain-fed watershed development areas, we could see a lot of improvements by constructing various interventions like contour bunding, nala bunds, check dams at different intervals, then constructing this kind of what you call small agriculture ponds in sloped area. At the end of our low-lying area, definitely we can achieve storage of water, which can be used for both agriculture as well as enhance the capacity of storage, surface water, and also which can be used for groundwater recharging. Definitely, it has seen a lot of positive development, progressive development, because we have assessed one of the watershed program which is being implemented by our watershed department of agriculture department. For 5 years, we have assessed and we have monitored the progress. We could see a lot of improvement in especially Bengaluru, Belgavi division.
Thank you, sir. Next question is, what is the best statistical method to be used to analyze data on rainwater quality and practice of rainwater harvesting?
Water quality of rain, definitely, as we all know that as a civil engineers, we know that rainwater is one of the purest form of water. Only thing is when it falls on top of your roof or on surface or on playground or road surface or on top of any kind of surface, when it gets mixed with different materials on roof or on surface, it gets polluted or contaminated. Depend upon the surface, depend upon the quality, we can go for testing of this water quality. And also the purpose of usage also plays very important role. Definitely, if it is being used for domestic, there's cooking and as well as drinking, definitely we have to ensure the quality. Then we have to use rainwater, which is being collected in rainwater storage tank. Or if it is for secondary purpose, definitely without any test, without any quality test, we can go for secondary purposes.
Thank you, sir. Sir, the last question is, what is the action initiated by government to implement rainwater harvesting? And is any subsidy provided by the government? If provided, what is the percentage?
See, as of now, there is no subsidy for go for rainwater harvesting. Of course, in both we could see a lot of mandatory rules being made by civic administration in both in Chennai as well as in Bengaluru also. Both BWSSP and Chennai Water Board also, they made rainwater harvesting compulsory, but there is no incentive or there is no subsidy for rainwater harvesting. But only thing is, because they're telling for each liter of water which is being supplied by civic bodies, it is costing about 45 to 50 rupees, whereas we are getting at the cost of 78 rupees. It is being subsidized actually. That is why should we give incentive, or why should we give subsidy for rainwater? This is what their version. So anyway, it is being under consideration, because in a lot of meetings as a technical committee member, we keep on stressing the government to go for at least 5 to 10% of incentive on water bills. But it is being under consideration by the government, but still it's not yet been materialized. But as of now, there is no subsidy or no incentives from the government. But as we all know that our water supply, whatever we are getting, definitely is subsidized only, because they're just charging out around 20% of the cost which they incur. Because it's they incur about 45 to 50 rupees for each liter. We get, I mean, for each 1,000 liters, we get about 78 rupees. This is what we get bills, no, water bills. That's why they're not giving any subsidy or incentives. But anyway, in future, definitely it is there. Of course, government has come up, all civic, urban local bodies, they're coming up and they're making mandatory. In Bengaluru, it is made mandatory. Even in Chennai, it's made mandatory. In many cities in India, they made mandatory. Even our local director of municipal administration, which is the main urban local body of our Karnataka, is making compulsory for rainwater harvesting in urban local bodies like city corporations, city municipal councils, or town municipal councils. It is under process.
Thank you very much for answering all our queries, sir.
Thank you.
Being civil engineers, we are all
Yeah.
responsible for the development of nation. The
Yeah,
development not only depends on improving our infrastructural facilities, it also depends on how effectively we utilize and conserve our natural resources for our future generations. The implementation of rainwater harvesting will definitely promote both water and energy conservation and results in sustainable development. In this context, I hope all our participants got benefited from your thoughts about various types of traditional water harvesting systems and different techniques of rainwater harvesting. Sir, once again, on behalf of AICTE, ISTE and Department of Civil Engineering, Jyoti Institute of Technology, we are very much thankful to you, sir, for accepting our invitation even in your busy schedule. We expect same kind of support and association with our institute for conducting more and more technical programs like this in the future also, sir. Thank you very much, sir.
Thank you. Finally, I also take this opportunity to thank the management and faculty of JIT Institute of Technology for taking pain in organizing this event, the week-long event, and also give me the opportunity to participate in this program. And also, finally, I thank all the participants who are participating across our country for patient hearing and patient and active participation. Thank you, one and all. Thank you very much.
Thank you, sir.
Thank you.
Dear participants, the attendance and feedback link is available in Zoom chat box. The next session will start exactly at 11:30 a.m.